Types of functions.
This time let's study inverse function.
Example: f of x equals x plus 5. If x equals 1, then f of 1 equals 1 plus 5, so f of 1 equals 6.
If x equals 3, then f of 3 equals 3 plus 5, so f of 3 equals 8. If x equals 4, then f of 4 equals 4 plus 5, so f of 4 equals 9.
Using the values we obtained, we have here the mapping of the domain and range for the function f of x equals x plus 5.
1 corresponds to 6, 3 corresponds to 8, and 4 corresponds to 9.
To get the inverse function of f of x equals x plus 5, change f of x to y, so y equals x plus 5. Then interchange x and y.
Then solve for y by transposing 5 to the right, so x minus 5 equals y. X minus 5 equals y is just the same as y equals x minus 5.
Then back to function notation by placing a -1 like a power or exponent to f.
Inverse function of x equals x minus 5.
If x equals 6, then the inverse function equals 6 minus 5, so it's equal to 1.
If x equals 8, then the inverse function is equal to 8 minus 5, so it's equal to 3.
If x equals 9, then the inverse function is equal to 9 minus 5, so it's equal to 4.
Let's compare the mapping of f of x equals x plus 5. Here we can see the domain and range are just interchanged when it comes to the inverse function equals x minus 5.
In the inverse function, the values of the domain are 6, 8 and 9, while the values of the range are 1, 3, and 4.
Let's graph from the pairs of coordinates f of x equals x plus 5. The points are 1, 6, 3, 8 and 4, 9. Connecting the points, we have here the graph of f of x equals x plus 5.
For the inverse, we have the points 6, 1, 8, 3 and 9, 4. Connecting the points, we have the graph of the inverse function equals x minus 5.
This is an example of a graph of inverse function of a linear function.
Some inverse are not considered a function.